This is Shrikar here, and today we'll be learning how to build a simple application using Streamlit and CursorAI, and this is the application we'll be building. So today morning, the MTA dataset open challenge was released, and I will be using one of the dataset and using ChatGPT to do the initial exploration, and then use CursorAI to build this Streamlit application. So let's get started. So to begin with, I just downloaded this data. So if you go to this particular data.ny.gov and do the MTA Express bus capacity dataset, you can go ahead and export the data, which will download the data as CSV. Along with that, I also want to download the overview and the data dictionary field. And these are the three files which we'll use and start our initial exploration in ChatGPT. For this particular example, let's see, let me just go ahead and add all the data set which we have downloaded from the MTA. So I'm going to copy and drag this data set here, right? So to begin with, I'm just going to start asking ChatGPT. I am providing a data set about the bus capacity. Can you look at the data and provide some insights into the data? This is what I'm going to start with, a simple exploration. Let's see what ChatGPT will come up with. It's kind of explaining right now what the data set looks like and what is the route. So here is an interesting part. It starts with the low load percentage, low load percentage during off peak, midnight is quite low, hourly variations, and it kind of talks about the APC data. Next thing is actually kind of provided an interesting artifact. Depending on the hour of the day, it's actually telling what is the average load percentage, which is an interesting one. It also kind of talks about the morning peak hours between 6 to 9, and apparently Bronx and Staten Island show a clear morning rush with higher load percentage. Other boroughs like Manhattan and Brooklyn see moderate increase in load, and same thing happens at the evening also, right? So one thing we can do is we can ask, okay, are there some optimizations we can do based on the say load percentage? Let's ask this question and let's see what it'll come up with. It's interesting, early morning 4 to 7 is kind of peak, and again it picks up after evening, after 2 p.m. It's interesting. Okay, optimizing bus routes based on the load percentage and can help improve efficiency and ensure better service for the passenger, which seems okay. Okay, the next thing is it's saying increase frequency during peak hours. For routes and boroughs showing high load, like Bronx and Staten Island, add more buses or increase the frequency to reduce overcrowding. This is an interesting point. Reduce frequency during off-peak hours. Okay, deploy smaller bus on low road routes. Okay, so this is also an interesting artifact. It's kind of providing us, if certain routes are consistently showing lower load, probably send a smaller bus, which is interesting. Reallocating bus sources between boroughs. Okay, so let's look at this particular point. This is interesting. So if we have to build a visualization, can we start with something simple, and then we can ask AI to help us build the application itself? So for this one, let's say, can you provide uh, a heat map for each route across different hours? Use red color coding if the load percentage is high, and light green if it's low. Let's see what it'll come up with. So this is just one example. So for example, it kind of talked about dynamic scheduling, route specific capacity optimization. These seems like a reasonable thing to do. and also the reallocating part. So if there is something quickly we can do, I just want to see understand. Okay, so this is interesting. Interactive charts of this type are not yet supported. Okay, but let's look at what the data shows. Open this one. If you look at this chart here, it kind of tells us that, okay, like during the morning hours, some of these routes are okay. What is really interesting is if you look at certain time like 4 to 5, so this one SIM3 looks like, and BXM7 route, they are orange, which means that they are like highly loaded. But the same thing like SIM5, SIM5 and SIM9, they're not loaded that much, right? So one thing could be like, can we just shuffle this buses around to kind of like help? Same thing happens like after 2, like there are like a lot of pockets where it's like less loaded. Like for example, BM1 to BM5 are most likely like less utilized as compared to other routes, like say SIM, still like Staten Island probably, and Bronx. So let's look at. So this is an interesting chart. What we can do is we can actually start asking uh, more questions on that. For example, let's look at reallocating is one thing which we talked about. If at all we wanted to reallocation, we want to reallocate. What is the best way to do it? It's kind of like reiterating the same thing. Can you provide an example? Can you provide actionable insights on the data set provided above? Okay, so this is kind of like but what we want is consistently load. Okay, okay, so then what we can probably do is something simple. So let's say, can you provide me a step by step, or actually let's say, can you convert the above into step by step requirements that we can explore and use to build a simple tool for visualization. Okay. Data-driven reallocation simulation, export and reporting option. I would say let's do it. It's okay. This is an interesting one, streamlit. You can probably try that. Not this one, sorry. Let's say we can even tell, can you also add logic to support reshuffle, reallocation of resources? What we want is a simple button which, when clicked, will show us how we want to reallocate. For this tool, let's use streamlit. I want you to provide detailed logic of how that should be implemented in Python. Please think through and provide a detailed instructions on how to build it. So this is like the first part of the application where we are going to just explore the data. Okay, it's actually giving us the code itself, but this is probably what we wanted to explore in Cursor. So this actually we can use it as a reference. But before that, let's say I just want you to provide the requirements. We will have Cursor AI. We will use Cursor AI to build the app, right? So let's see. It's kind of like telling us what it needs to do, right? So what we are gonna do now is we're just gonna take this one and let's try something which we have not tried before. I don't know if it'll actually even work, but let's try. So now I have this data in the MTA dataset. What I'm going to do is I'm going to open a new file called requirements. It's basically say instructions.md, or rather instruction.txt probably. All right. This is what I have. I'll save it. Now at this point in time, I'm just going to go full cursor AI mode. Command Shift I. It's going to open the composer view. So I'm going to say, please read the instructions.txt at instructions.txt and help me build a visualization app using Streamlit and follow the requirements step by step. Create the code and install necessary applications or like necessary libraries. Let's see. As you can see, started with something already. Let's look at this. Setting up the page config, wide, whatnot. And then we have burrow level analysis. Interesting. It's actually creating like an app.py also. Did we actually install the application, or did it tell anything about requirement.txt? Okay, so this is the requirement.txt it suggested. So what we are going to do now is, let's say, accept all, right? At this point in time, let me just close the composer view, open up the window or like say terminal, and then I'm going to do pip install -r requirement.txt. At this point in time, it will go ahead and install all the packages which we need. And we are going to start the Streamlit app and see what it initially provided. And then we can take it from there. It's taking some time. Let's see. I think what is really interesting is like just bootstrapping this whole application and like the steps or like brainstorming ideas on what we can build is pretty powerful. Now let's start the Streamlit run app.py. Right, it's gonna open this particular file. Let's see what the data looks like. I don't know if it actually picked up the data set. Uploaded file, it's not there. Oh, it's actually asking us to upload the file. That's fine. Right, so it's interesting. Or we can actually, let's say, how about we do this one? We can even ask it to say, use the data. I'm just gonna open the side view. Use the mta underscore data.csv and load that file for this application. Right now, instead of like we kind of uploading the file, we're asking it to like change the code itself to make it happen. So it made the change, apply, accept. At this point in time, let's go back, refresh again here. So as you can see, like the early data set, the roadmap is done. Select the route 1, NB and southbound. That's the direction. Load percentage is like this load percentage is weird. I don't even know what that means. It's 15K. So okay, this is Bronx. This is peak, and oh, this peak is off peak. Dark blue is like off peak, and light blue is peak. So load percentage, Staten Island on average, and Brooklyn seems to be on the higher side comparatively, right? So let's see what it'll actually provide us. So if I do BXM10, so I don't know what the load percentage is. What is the load percentage value? We can just take the screenshot and we can actually ask cursor. I don't understand this chart. Understand this chart. What do the axis mean? And is there a better way to visualize this data? Right? Um, Correct. So it's saying that the scale is not right. Let's see what it's telling us to do. Accept. Will that help? Kind of. It's okay. So now it's like hour of day. Now at least like we can make some sense, right? So northbound, that's like the peak time around 6, and then probably like a lot of people travel northbound from PXM, that particular route. After 12, it's kind of like the load has been increasing to 33 to 35, but it is still not that high, right? It's kind of like even telling the distribution of load percentage. We can tell individual route doesn't make sense. Can you provide how the overall data looks like for different routes to find routes that need optimization? This is literally like we kind of are talking with the data and telling what they should do. Let's see. So this is done. Certainly, it's going to like update certain things, update the route comparison. Sure. Let's do this. Apply, accept. I think I don't remember if we installed Plotly. Okay, now it's kind of like complaining about series type error. You can just take this and then put it here. Let's see if it can actually do that. Okay. Sure. It's gonna apply this, accept it. The main change is this one, rerun. Yeah. So for example, oh, this is interesting. Average load percentage by route. So wow, this is a very interesting part. Like, so if you look at this one, right, like all these are the routes which are heavily have a higher load percentage as compared to these ones here. So it kind of makes sense if we can. What is also interesting is this one. Like load percentage is very small. Is it possible that we can shuffle some buses from this area, this QM44 to this these sim routes? So that's a possibility we can think of. There's also like hourly load percentage heat maps for all route. Again, smaller. So there is like some pocket here, like 1 o'clock, SM8, SM9, 83. That's insane. There's also like 100%. That's crazy. Um, There's also something here, like around 11 o'clock. I wonder what's there we can actually ask what could be the reason for higher bus utilization in Staten Island route during 1 p.m. and 11 p.m. midnight. Okay, looks like they are doing something. MTA approves adding more buses for the selected Y during peak hours. That's they are kind of like doing something. So the Staten Island local bus service things. Okay, it kind of like it's obvious that people are complaining about it. So there's something we can certainly do. Let's think about the next steps here. So we can actually tell, can you reshuffle? Can you provide a way to simulate um, or shuffle buses around to reduce the load? Right. Okay, certainly can help you with creating a simple simulation to distribute buses and reduce the load. We'll add a section of the app that allows user to interactively adjust bus allocation or see the impact. Right. Okay, let's see. Let's try. Let's see what it will provide us with. It's gonna say rerun. Oh, I didn't apply actually. Apply accept. Now if I go rerun, it's probably going to understand like bus simulation. I don't know what this thing is actually. Huh, it did something crazy. Now let's see actually what will happen. Okay, did anything change? Okay, so basically new load is probably going to be this one. Okay, interesting. Original load, because we increased the bus, that's what it is telling us. But this is what manually, I don't want to do manually. Okay, we can ask now. Okay, I don't want to adjust each route manually. Can you provide some tools to look at routes during peak time and move buses from low utilization to higher utilization? Just say that. Let's see what it will provide us now. Okay, it's taking something. So the 7, 8, 9, 16, 17, and 18 is kind of like taking it as a peak peak optimization route at the times. Let's see what it will provide us now. Roads still needing an attention. That's interesting. So apply to enter file. Let's see, it's gonna change that one. It's actually doing a lot of writing the code right now. Accept it. Save, then go back, rerun, peak time optimization, load percentage. Okay, so target load percentage is what I want, new load. So, okay, original load and new load. If I do this one, change this. Interesting. Okay. First changes, load percentage change. So if I, oh, this is interesting. So whenever by adjusting this reallocation, it's telling us how the load will change. Initial buses are 6, needed buses 111. That's kind of extreme. New load percentage, this is too small. It goes from 52 to 3. That's probably not what we want. Let's change the load thing to like 52. Right? So sim 1 I think it's sim 1 is a bit extreme for some reason. So otherwise, I think what you can see is like it has helped reduced certain utilization. Load percentage was 38, now it becomes 50. So some of them roads were like underutilized. So for example, I think it was QM. Yeah, QM 35. Initial buses were 3, it reduced to 2. Now the load percentage kind of like increases. But there is something funky going on with SM1, right? It's literally taking every route and then putting it to, so SM1 is still like the load percentage is very high, and that's probably what it is trying to optimize for now. Or maybe it's doing something with whatever I picked here. Two. Okay. I wonder if things will change now. I don't think so. We need this, to be frank. Let's see. Okay, this is interesting. Average load before reallocation was 31. Okay, why is this one? Why is SIM1 going from high overload to underload? Why are we moving 67 buses to that route? Can I just recheck the logic? Yeah, I think overall it's doing good, except for that one. Just one is like kind of weird. But otherwise, if you look at all the other ones, right, like it has adjusted from like 19 to 39, 18 to 37. It's taking one or two routes from those buses, like those routes, and then allocating it to 67 of the sim one. You're right. Reallocation, okay, that's good. Let's see. Apply to the entire file. Target load, okay. Let's accept this one and then take it from there. Accept it. Save. Rerun. Okay, target load is not defined. We can just check. Define. Just apply it. Now I'm going to add one more thing. If the target load can't be achieved, tell us how many more buses do we need extra, right? So accept it, allocation, rerun. It's gonna say allocation changes, sim1, initial buses 6, buses needed is 9. Okay, this is interesting. So this actually makes sense. Now I think it went from 6 to 9, 5 to 8, sim1, because these were the ones, if you look at this route, sim1, sim10, and those were the ones which had like very high load. So it's kind of like telling, okay, we can get the buses from like lower utilized ones to higher utilization one. So all the routes which had like very low percentage load percentage, it kind of reduces QM32, goes from like 2 to 1, and new load percentage is 32. Bus changes is 1, but for some of these roads, like we add like few more buses, which is really good. Our total allocation is like buses is 281, buses reallocated is 57, average load before reallocation is 31, average load after reallocation is 36.5, right? So I would say this is like a pretty good start. But as you can see, like within like 15-20 minutes, we were able to like start with something reasonable. Like even like simple understanding of like the routes, understanding the heat map, what else we could do. Um, so yeah, this is like what I just wanted to show today, of how to like start using ChatGPT for initial brainstorming or exploration, and then use it to generate some kind of a requirement set. Take those requirements, add it to the cursor.ai, and then build out the whole like Streamlit app, right? So yeah, that's it for today. Please let me know if you have any questions. I'm also going to clean up a little bit of this application because I think these are like probably overkill. I'm going to remove them and just keep like only the main sections in this tool. Thank you, folks.